Okay, so hi everyone. For this week, we will have a revision for quiz one. So we will have from week one till week four. So first we'll start with solving simple problems, and then we can move on to some advanced problems as well. Okay, so we'll continue the same for today and on Friday also. Okay,
Good evening, ma'am.
so good evening. Okay. So before starting with the problems, do anyone have any doubts in any weeks 1 to 4? Okay. So if you don't have doubts, then we can start with solving few problems. And if you don't understand anything, then along the way we can learn it. Okay. 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 So for the first problem, let's say you have an inverter. So let's say you have an inverter. Okay, and for this inverter, the values of VIL, VIH, VOL, and VOH is given. That is VIL, VOL, VIH, and VOH. Okay, so it is 1.4, 1.4 volt. VIH we have 3.4 volt, and then for VOL 0.9 volt, and for VOL you have 4.4 volt. Okay, so now for this question you have to find uh, noise margin low. Noise margin low, that is NML. So how will you solve it? What is the formula to find noise margin low? You all solved this in week one, right? You would have also solved your assignments also. Okay. So if you want to find noise margin low, what you have to do is you will have VIL minus VOL. So V input low minus V output low. So what is VIL? 1.4 minus what is VOL? 0.9. So what is the value now? 0.5, right? Am I audible? Okay. Then moving on to second one, noise margin high for the same question. So for the same question, we have to find noise margin high. What is the value? NMH. What is the value for this?
It will be VOH minus VIH, which is equals to 1.
minus, okay, it is 4.4 minus 3.4 is equal to 1. Okay, okay, then moving on to next type of question. Suppose you're having two's complement representation for a given number is presentation for a given number is 1 2 3 4 base 2. Now you have to find the equivalent of that number, of this number in base 6. Can you solve this and let me know? Can you try? Did anyone solve? Is anyone solving? Can let me know how you're trying to proceed with it. Okay, so how did you proceed with it? So how do you solve it?
First, here we'll invert the bits. We'll get 0, 0, 0, 0, and
Mm,
then add 1 to it. will get 1.
Mm,
As here we can see that the MSB is 1, so it is negative, so we'll get -1
mm,
as a negative number. And again, we'll try to convert, take 4 bits for the for converting 1 to into hexadecimal. So it
mm.
will be 0001, and then again we'll find the tooth complement for the, and we'll get F.
Yes, correct. So first you will have 0, 0, 1, 1, 1, 1. You invert the bits to get 0, 0, 0, 0. You add +1, then you get 0, 0, 0, 1. And now we know that because MSB is 1, it is a negative number, so it is -1. And to find the equivalent for this number in hexadecimal, again we'll follow the same steps, and then subsequently, when as you told, when you do it, you will get F. Okay. So moving on to next question. So now let's say you have a 2's complement number. 2's complement number, 2's complement representation of a number, representation of a number of n bit number. Okay, 2's of n bit number. So now how many zeros are there? You're trying to zeros are there when you're trying to represent -1. Okay, so -1 you're trying to represent it into complement representation n bit format. So how many zeros will be there? N minus 1. How is it n minus 1? How do you represent -1 into its complement? Zero. Yes, it is 0. Will you be able to explain how? Okay, so +1. What is your +1 representation? Okay, let's take a 4-bit number now. So +1, how do you represent +1 in 4-bit? 0001, right?
Yes, ma'am.
Okay. And now tell me 2's complement representation of -1. How do you do? You have 0001, then you invert.
Inputting the bits 1110 and then adding +1.
So it is 1111. So this is your 2's complement representation of -1. Now how many zeros will be there?
Zero.
Zero. Correct. So there are zeros in the 2's complement representation. Then how many number of ones will be there? N ones, right? N, it is n bit number, so there will be n ones. Because for minus 1, all the digits will be 1. Any doubt in this? Okay, yeah, n, correct. Okay, now let's say you're having 2's complement form of 2's complement 2's complement form for two numbers. Okay, for the first one, it is 1, 2, 3, 4, 0, 1, 0, 1. This is the first one, and the second number will be 1, 2, 3, 4, 5, 6. 0, 1, 0, 1. Okay, these are the two numbers in the 2's complement format. So for these numbers, are they equivalent? You have to find, are they equivalent? Okay, can you solve this and let me know if they're equivalent or different? You have two numbers in the form of 2's complement. You have to find if they are equal or not.
Yes, ma'am, both are equivalent.
Yes, both are equivalent. So can you tell how? How did you solve it?
First, we'll convert into decimal value and we can check it. Like, first we have to invert the bits and then add 1 for the first one, and for the second one also we'll do the same process and we'll get -11 for the both the decimal
Correct. It
value.
is minus 11. Correct. So they both are same. Okay. It's clear for everyone, right? Or do we have to solve this? It's clear, right? Okay. Okay. Now moving on to next question. Let's say your f of a, b, c can be written in the min terms as 0, 2, 4, 6. So now f of a, b, c in terms of max term, what is it?
1, 3, 5, 7.
1, 3, 5, 7. Yes, correct. So how we solve it? For min terms, we have 0, 2, 4, 6. And for three variables, it is 2 power 3. So there are 8 possibilities. And out of 8, we have 4 in the min term. So whichever is not in the minterm, that will come to the max term. 0 and 1, 2, 3, 5 and 7. I hope it's clear with everyone, right?
Yes, ma'am.
Okay. Okay, now let's take f of ABC will be equal to A, B, E, A dash, B plus C dash. Okay. And G of ABC will be A plus B dash into C the whole dash. Okay. Now, can you find if F is equal to G or no? Okay, so we solve it together. Yes, both are equal, correct. So how? So if your F is A dash dot B plus C dash and your G is A plus B dash C the whole dash. Now let's start from G. Okay, let's solve G. So according to De Morgan's law, when you convert this, what will you get using De Morgan's law? A plus B bar, the whole bar, and will become OR and C bar. Correct? And again the same thing, De Morgan's law for this. A bar, OR will become and B bar, the whole bar, plus C bar. So now it is A bar, B bar, the whole bar becomes B plus C bar. Now is this equal to F? Yes. So it is equal. Okay. You can also solve from F. So if you're having A, so if you're having A, B plus C bar. We have to solve from F towards G. What you have to do? You have to use the which law? Which law will you use? You can also use the distributive law. Okay, can use distributive law and go from this towards G as well. But looking at this, we can easily find out, right, that it is easier this way using De Morgan's law. You can just go towards F. So this is easier, and so you can follow this one. Okay. Okay. So let's say this is your circuit diagram. Okay. So this is our circuit diagram. So in this diagram, the output y is equal to 1 when input a is equal to b dash. Y will be equal to 1 when input a is equal to b dash. And c, what will be c value? That is when a is equal to b dash and c is equal to certain binary number, then y will be equal to 1. So you have to find out what should be the input value of c to have y is equal to 1. Can you solve this now?
Yes, ma'am.
Okay. Yes, correct. C is equal to 0. So how? Now if we are solving this, what will be the value of P when we have A is equal to B dash? At P, what will be the value?
Uh, we have to simplify, like we'll get b dot b complement, the whole complement, and for the simplification we'll get 1, because b dot b complement will be 0 and the whole complement will get 1.
Correct. So at P, you will have 1. Now similarly, if we are solving for Q, what will be the value at Q?
0.
0, because again you're having OR, right? So for Q, it will be A plus B the whole complement. Same thing, B complement plus B will give you 1, the whole complement will give you 0. Okay, now what will be the value at R? P is 1, Q is 0, so the R will be
0.
correct, 0. So now at Y, the R will be 0. Now at Y, what is Y in terms of R and C? Which gate is it?
No,
Sorry?
it's not a.
Correct, it is X NOR gate. So what is the truth table for XNOR gate? When will you get 0 and 1?
For two same input, we'll get logical high input, and for two different input, we'll get logically low input.
Correct. For 0 0 you have 1, 0 1 will be 0, 1 0 will be 0, and 1 1 will be 1. Okay. So for this is the truth table, and for this we know that R is equal to 0. You're having R, and what is it is R and C, right? So if R is 0, let's say this is your C and this is your R, and we know that we need Y is equal to 1. Now if the R is 0 and you need Y as 1, what will be the value of C? It is 0. Okay. So to solve these all problems, you should be very well aware of what is the truth table for the different kind of gates like XOR, NAND, NOR. Should know all the gates. Truth table for the gates. Okay. Now let's take so for the similar question. Okay. Yeah. For the similar question, let's take the same one. If you have C as 0 and A is equal to B, then what is A? What is the value of A? So for this, your Y will be equal to 1. So now you have to find what is the value of A. Are you able to solve for A?
A equals 1.
Yes, yes, it's correct. So how we solve? Again the same procedure. We find P. P is A B the whole bar, and we know A is B. So B dot B is B complement. Similarly for Q, it is A plus for Q it is A plus B the whole complement, and B plus B again it is B, correct? And then now
Yes.
for R. R is P Q, which is equal to again B complement dot uh, B complement dot B complement, what will it be?
It will be same B complement.
Correct. So now finally your y will be equal to r x naught c, right? And for this, what is your r? B complement. And what is your c? 0. It is given, no? 0. And we know that y should be equal to 1. And the same x naught table, when you want 1 and one particular value is 0, then your b dash will be equal to
0.
correct. So if that is 0, your b is 1. We know that a is equal to b, so a is also 1. Okay. Now for the same equation, now let's say this one, okay? The same circuit diagram we are trying to find in terms of SOP and POS. Have to find Y in terms of SOP and POS. Or let's just make it simple for now. Try to find Y in terms of min terms and Y in terms of max terms. Can you find this two first in terms of min terms and max terms? It is A, B, C, okay? So A will be the MSB and C will be the LSB. Midterm is 2, 4, 6. Next term is the rest. Okay, let's see. Okay, so now what is the value at point P? This A be the whole complement, and at Q it is A plus B the whole complement, and at R it is AB complement and A plus B the whole complement. And this can also be written as, what is A plus B the whole complement?
A complement dot B complement.
A complement dot B complement. So now R, now Y. Y is R x naught, R x naught C. What is your R? Okay, for x naught, what is the value? What is the Boolean expression for x naught?
RC,
Is
A dot and a
RC
circle around it.
R complement C complement.
correct. R complement, C complement. So now here, what is your R? And here, can you simplify this more? A B the whole complement, A complement, B complement. Can you simplify this more? For this, A complement plus B complement. Then you have A complement, B complement. Now we can perform distributive law here, right?
Yes, ma'am.
So you will get A complement, B complement plus B complement, which is A complement, B complement. Now what is the value here?
It will be A complement B complement.
Let's end this one,
This is also same A complement B complement.
and this will be,
A complement B complement.
now this is your R. So now your R is, and okay, to make this more sure, what will this become? Will this be equal to this? This is
Yes,
correct.
yes, ma'am.
Okay. So now, or you can write it anyway, it's fine, but okay. So now it is A, B, C plus R dash. What will be your R dash? A plus B, C complement. Correct? So now this will be A complement, B complement, C plus A plus B, C. So what will this be? A, A complement, B complement, C plus, if you use distributive law here, what will it be? A C complement plus B C complement, right?
Yes, ma'am.
And what we were trying to find? We were trying to find the midterms. So now if we have A, B, C, if we don't have term, how do we introduce B term here?
We'll take B plus B complement.
B plus B complement. So this will be A, B, C, C complement plus A, B complement, C complement. Similarly, for this we will introduce A complement. So that will be A, B, C complement, which will be same as this one, plus A complement, B, C complement. Correct? Now what will be for this one? What is the min term for the first one? This is 0, 0, 1. What is 0, 0, 1? 1, right? 1, 1, 0 will be simplification part. Okay. R simplification, or are we talking about Y? Do you want a simplification of R or Y?
And the simplification part R dot C and R bar dot C.
Okay. Okay. RC plus R bar dot C. Okay. So you have your Y as RC plus R bar C bar. So this is the value for R X naught C. So what we found out is we are having our R as, from here we found that R is this one. This is our R. So here we are substituting the same value, A bar, B bar into C, plus R will be A plus B the whole bar. So R bar will be A plus B the whole bar, the whole bar. The complement and complement will get cancelled and it will become A plus B. So R bar will be A plus C into C bar. Okay. So now here what we are doing is, here this is also AND gate, this is also AND gate. So this will become A bar, B bar and C. This is fine. But when you're having an OR and then you're having an AND, what we will do is we will do distributive law. We'll perform distributive law. So how you'll have distributive law is this will come here and with this. So this will be A and C bar plus B and C bar. Okay. So now you have A bar, B bar, C plus A, C bar plus B, C bar. And uh, another thing is, whenever you want to find min terms or max terms, it will be easier if you have all the three terms. It is three, right? In the question you have A, B, C. So if you have all the three terms, it will be easier for you to find it. So to introduce that, what we will do is, what is B plus B bar or anything, let's say X plus X bar. What is X plus X bar?
One.
1.
1, right? So if you are having X plus X bar as 1 and you're trying to introduce this term into any existing term, this and X plus X bar, what will happen? We know already this is 1. So AC bar and 1. What will be the value of this? AC bar, it will remain same. So what we are trying to tell is, even if we introduce X plus X bar and gate with the existing term, it will not change the value. So as it's not changing the value, we are just introducing this but not changing the value. That if you want an analogy, right? So let's say you're
Excuse me,
having, mm,
ma'am, I am asking something different.
what else simplification do we have? That is the
Ma'am,
only
this
simplification.
one like this one like how did you do, ma'am? A bar plus B bar then dot A bar dot B bar. Ma'am, how did you simplify it? And this one R part.
This one?
No, the upper one.
This one?
No, ma'am, little right.
This one?
Yeah, yeah, ma'am, this one.
Okay, so we are trying to, you want to solve for R, okay. So for R, if you see for R here, the value is PQ, AND gate PQ. So what is P? So value of P here will be AB the whole bar. Value of Q will be A plus B the whole bar. So for R, your P is AB the whole bar and your Q is A plus B the whole bar. So again what I'm doing is I'm using De Morgan's law here. De Morgan's law for A plus B the whole bar will be A bar and B bar, right? And if you are using De Morgan's law for A, B the whole bar, that will be A bar plus B bar. Is this clear?
Yes, ma'am.
Okay, so now if I'm substituting that here, A bar plus B bar and gate, for A plus B I have A bar dot B bar. Again, what we can do is you can have a distributive law. A bar will be equal, will get AND gate with this one plus B bar with this one. This as in the whole term, okay? Because if you see, as I told here, you have OR, but this is and this is also AND. So bringing this here, you will have A bar and A bar B bar plus B bar and have A bar B bar. So let me go down. So you have A bar and A bar B bar plus B bar and A bar B bar. So now again everything is AND, right? So you have A bar and A bar and B bar plus B bar and A bar and B bar. So A complement and A complement, what will it be? A complement, right? So it will be A B bar, and same thing, B complement and B complement will give you B complement. So now you're having A complement, B complement plus A complement and B complement. So what will these two terms have? These two terms are same and you're doing the OR gate. So what will have? You'll have the same term, right?
Yes, ma'am.
So it will be A bar B bar. And using the De Morgan's law, what we are trying to tell is this will be A plus B the whole
Yes,
bar.
ma'am.
This will also be equal to A bar and B bar. Okay.
Yes, ma'am.
Now is this clear? Clear, right?
Yes, ma'am.
Yeah. So, so where were we? Yeah. So we got the terms here, and if we are introducing B for this, then you will have A bar, B bar C plus A B C bar.
Ma'am, understood this part.
You understood, right? Okay. So it is A B bar C bar plus, and now we are introducing A plus A bar. So again, it will be A B C bar, which is the same. So I'm not repeating it. Then you have A bar B C bar. So now this term, what will be this term? 001 will be 1. 110 will be 6. 100 is 4. 010 is 2. So your min term will be 1, 2, 4, 6. Your min term is 1, 2, 4, 6. Your max term will be
0357.
5, 7. Correct. Okay. So this is how you will be able to find your min term and max terms from the circuit diagram. Okay. So any doubt in this question or is it clear? Okay. So I hope it's clear for everyone. Okay. So I have another